this is Riya, and in this program I'm going to demonstrate the working of a stack of size n using an array. The elements of a stack may be assumed to be of type integer. Now in this program 3 operations may be performed: push, pop and display, and the program should print appropriate messages for stack overflow and stack underflow. So in this program we have declared some of the functions such as push, pop, display, is full, is empty. Now we have declared some of the variables above the main function, above the main method, for example such as top is equal to -1, n, data and array of 10. Now why have we declared all these variables above the main? It's because so that these variables can be accessed in any block of the program, because these variables are called as global variables if it is declared outside the main. Now if it would have been displayed inside the main, then that would have been local to that particular block. So to avoid this, we are declaring it outside the main method. Now inside the main method, this program basically is a menu driven program, so we'll be giving menu to the user using switch case. Now this switch case will be under do while loop, which will help the user to choose the operation he or she wants to perform. Okay, so here the user has to enter the size of the stack, and based on what he or she wants to perform, he may opt for choice 1, choice 2 or choice 3. The choice 1 is push, choice 2 is pop and choice 3 is display. Now once the function is completed, the compiler will ask whether the user wants to continue or not. If he or she wants to continue, then he has to press either capital Y or small y. Now under the function is empty, we are saying that if top equal to -1, then we are returning 1, else we are returning 0. Now this top is equal to -1 indicates that there are no elements in the stack, and once there are no elements in the stack, then 1 is returned. Else if there are elements in the stack, then 0 is returned. Now in the function is full, we see that this n is actually the maximum number of elements that can be accommodated in a stack. So if in is full function, if top equal to maximum -1, that is n over here, then we will be returning 1, else we will be returning 0. Okay, now these is full and is empty will be used in the coming functions like push and pop. Now in push, first of all we will see that whether the stack is full or not, because if the stack is full, then we will not be having any space for pushing any new element into the stack. So we'll be checking the condition that if is full equal to 1, if it is true, then the compiler will be displaying that stack is overflowing, else the required action will be performed, else then top will be incremented to +1, and then in that position the particular data will be stored. Okay, and similarly in the pop function we are saying that first of all we are checking whether the stack is empty or not, because if the stack is empty, there won't be any element that we will be able to delete. So first of all we'll be checking if is empty equal to 1. If yes, then the compiler will show that the stack is empty, else there will be we are keeping a variable over here which will be holding the topmost element of the stack, and finally it will be displaying that the deleted element is that particular variable, and then the top is decremented by 1 value. Now this is the pop operation. Now if you want to display the elements that are in the stack, then we will be first of all checking whether the stack is empty or not, because if the stack is empty, then there won't be any elements to display. So if this condition is true, then there won't be any display operation and it will be showing that the stack is empty. Else we'll be using a for loop in order to display the elements of the stack. So the for loop will be int I is equal to 0, int less than equal to top, and I++, and then it will be displayed, and the elements of the stack will be displayed. Now let us see how this program actually works. Now let us enter the size of the stack. Suppose we take it as 5, and then it is asking the user to enter the choice. Like suppose we are entering 1, and enter the element to be pushed into the stack. Suppose if we enter 23, that means this is the first element of the stack. Now the compiler is asking whether you want to continue, and if we press Y, then yes, they are showing the options again. So if we want to push another element into the stack, then we have to again press 1, and then we'll enter the item to be pushed into the stack. Now this element which has been pushed into the stack is the second element, okay, which is the topmost element. Now again, if we want to continue, then again the option, we have to press Y, and then the options will be shown. Now again, if we press 3, then it will display whatever elements are present in the stack. So 23 and 56 were the elements that we had pushed into the stack, and they are showing it, and the compiler is showing it. Now if you want to continue again, then we have to press Y. Now if we want to pop an element of the stack, then we press 2, and the element which was pushed last will be deleted, and it is displaying that the deleted element is 56. Then again, if you want to continue, and if you want to delete another element, then we will press 2, and it will show the deleted element is 23. Now again we press Y, and if we want to delete something, it shows the stack is empty because the 2 elements that we had pushed into the stack, we already popped it out right now. So there is no more element in the stack, and so it is displaying the stack is empty, and we cannot display anything, and the compiler is showing that the stack is empty.
Hi, this is Riya, and in this program I'm going to explain how to write the code for the conversion of an Infix expression to Postfix expression. Now while writing the code for this program, we have to ensure that all the precedence and associations of operators, that is plus, minus, into, division, power, equal to, are followed during the conversion. Now let us see how to write the code for this program, but before that we'll discuss what is infix expression. In an infix expression, the operators are written in between the operands, and in postfix expression, the operators are written after the operands. Now let us see how to write the code for this program. We'll be declaring the header file and the standard library functions, then standard library function, and then we'll be declaring a character array of size 50. Then after that, we'll be initializing top equal to -1. Now this top will be a global variable which means it can be accessed in any part of this particular program. Now we'll be defining the functions such as push, pop, and a precedence function, which will be used throughout the program. Now inside this push function, in push function we have to pass an element of type character. Now inside this push function, we'll see first of all the top, which was initially -1, has been incremented by 1 value, and in this position this element is passed. Now after that, in pop function we see that the value which was at this particular position, that is s of top, is returned, and then the top has been decremented by 1. Then inside this function, that is precedence function, we pass an element of type character, and inside this particular function we have a switch case which will be checking the precedence order. So first of all, for hash 0 will be returned, and then for open bracket 1 will be returned. Since plus and minus has got equal precedence, so 2 will be returned, and since into and division has got equal precedence, so 3 will be returned. Now the work of the functions is over. I mean, we have finished declaring the functions and the operations which has to be performed inside that particular function. We have finished all those. Now we'll see what has to be done in the main function. Now inside the main function we'll be declaring 2 array. One is infix, which is of size 50, and then postfix, which is of size 50 again. Then we'll be declaring ch and element. Now will be initializing I equal to 0 and k is equal to 0. Now the user has to enter an infix expression which has to be converted into a postfix expression. Now first of all, there's a function call over here that is push. Now after seeing, now this has been passed. Now this particular function will be called, and then the this particular operation will be carried out. After this, there is a while over here. Now this will be checking the infix expression from left to right. Now this will run until it has reached the last part of that infix expression, that is, if it is not equal to null, then we will come inside of this while loop. Now this will run until the character becomes equal to null. Now inside this while loop we'll be checking if the character is equal to open bracket. Now if it is so, then we'll be pushing this particular character inside the stack. Then we'll be having another else if statement in which it's checking whether is alnum of ch. Now is alnum is a function which will be checking whether the character is alphanumeric. Alphanumeric in the sense it will be checking whether the character is either between 0 to 9 or from capital A to capital Z or from small a to small z. Now once this statement, if this condition is true, it will come inside of this particular if statement, and then we'll be storing this particular character inside this postfix array. After this character has been stored inside the postfix array, then k will be incremented by 1. Then if this statement is also not true, then we will we'll see there's another else if statement, that is else if ch equal to close bracket. Now since if this statement is, if this condition is true, we'll come inside and we find that there's another while loop, that is if s of top not equal to open bracket, then again pop operation will be carried out, and that element will be stored in this particular position, that is postfix of k. After that, k will be incremented by 1, and this popped out element will be stored in this variable which we had declared above. Now if this condition is not true, then we have another else statement inside which we have another while loop which will be checking the precedence order, that is PR s of top greater than equal to PR ch. If this is true, then the popped out element will be stored in the postfix stack, postfix array, that is that element will be stored, and then k will be incremented by 1. After that, the value of the character will be pushed into the stack. Now if this while once this particular condition becomes false, we will come out of this particular while loop, and then we find that we have another while loop, that is s of top not equal to hash. Now if s of top is not equal to hash, then pop operation will be carried out, and that the popped out element will be stored inside this postfix, inside this particular position, that is postfix of k, and after that element is stored, k will be incremented by 1. Then this particular process will be carried out until the infix expression, the character has reached the null character, that is the total number of characters will be checked. After that, if it is equal to null, then the program stops, and then we have to display the postfix expression. Now let us see how this program runs. So let us enter an infix expression, that is 2 plus 3 into 4 minus 5. Yeah, that's it. Now we can see the output, that is given infix expression as 2 plus 3 into 4 minus 5, and the postfix expression is 2 into 3, 2, 3, 4 into plus 5 minus. Now this is the required postfix expression. Thank you.